Welcome back. It is January 18th, 2026, and in 5 days, on January 22nd, something is pointing directly at Earth, and it is not supposed to exist according to everything we thought we knew. Harvard professor Avi Loeb has just released new calculations and data that fundamentally challenge our understanding of interstellar objects. 3I Atlas, the visitor from deep space now transiting our solar system, is exhibiting three behaviors that natural comets simply cannot produce. Its rotation is synchronized precisely with the Sun. It displays a mechanical-like heartbeat pulsing every 7 hours, and its shape and material properties appear to violate conventional physics. Every major telescope on the planet is being redirected to capture what happens next. We have roughly 1 week to scan this object in extraordinary detail before it slips permanently into the void. 3 key updates, 3 major anomalies, and 1 question no one wants to voice openly. But before we go any deeper, let me be very clear. This video separates published observations from interpretation and speculation. What follows is grounded in peer-reviewed data and the active scientific debate right now. Stay for the evidence. Question everything. Here is what is actually happening. First, the January 22nd alignment window. Avi Loeb, together with physicist Marco Barbieri, published precise orbital calculations showing that on this date, 3I Atlas will align almost exactly along the Earth-Sun line to within 0.69 degrees. For context, that is roughly 10 times more precise than any previous interstellar object we have observed. This geometry triggers a rare and powerful optical phenomenon known as opposition surge, studied since the Apollo lunar landings. When Earth, Sun, and target align perfectly, shadows disappear and coherent backscattering occurs, a quantum optical effect that reveals microscopic surface texture in dramatic fashion. Apollo astronauts observed this as a bright halo encircling their own shadows on the lunar regolith. To visualize coherent backscattering, picture driving through dense fog with headlights on. The light scatters diffusely in every direction, but if you stand directly behind your own beam, the droplets reflect light straight back, creating an intense glare. That is precisely the setup we are about to witness with 3I Atlas. The Sun acts as the flashlight, the dust envelope around the object is the fog, and Earth is stepping directly into the glare path. This is not merely a visual spectacle, it is a diagnostic scan. The exact width and profile of the brightness spike will constrain the microscopic texture of the surface and near-surface material. A narrow, sharp spike would indicate compact, sintered, or processed rock. A broad, diffuse spike would point to fluffy, pristine, low-density aggregates that have grown gently over billions of years in vacuum. In the coming days, we will learn whether 3I Atlas resembles standard solar system gravel or something markedly different. This alignment window is narrow, centered on January 22nd and lasting roughly a week. During this period, we will be looking straight down the anti-tail, directly into the wake of this interstellar traveler. Why is such precise alignment so uncommon? In the history of astronomy, we have had only a handful of opportunities to observe any comet at this exact phase angle. Most objects pass well above or below Earth's orbital plane. 3I Atlas is exceptional. It entered from deep interstellar space, sliced through the inner solar system, and is now departing on a trajectory that lines up almost perfectly with our line of sight. The geometry feels almost deliberate. This brings us to one of the highest value astronomical observing opportunities in recent memory. Behind the scenes right now, every major facility is competing for telescope time. Directors' discretionary allocations at Hubble and the James Webb Space Telescope are being redirected. Why the urgency? Because 0.69 degrees is the keyhole. At this precise phase angle, we gain access to information normally hidden. Specifically, the porosity and structure of the dust grains. If the dust consists of fractal aggregates, fluffy, delicate structures built slowly in deep space over eons, the coherent backscattering will produce a characteristic wide scattering cone. If instead the material is processed, ground alloy, ceramic, ablation shielding, or engineered composite, it will scatter light differently, appearing smoother and more uniform. On January 22nd, we will not just measure total brightness, we will probe microscopic material properties from hundreds of millions of kilometers away, effectively turning the opposition surge into a remote microscope. Now the story turns even stranger. Using Hubble data, Avi Loeb and astronomer Tony Scarfato measured the rotation period at 7.1 hours, precise, stable, and highly regular. They tracked jet positions across repeated observations and discovered that the jet orientation wobbles by roughly 20 degrees, while brightness varies by about 30%, all locked to the same 7-hour cycle. Loeb describes this as heartbeat variability. Picture a mechanical pump cycling rhythmically. Here, the jets are expelling dust and gas in periodic surges, modulating the coma brightness in lockstep. This is not chaotic, random sublimation. It is clockwork-like, and the activity is intense. The object is ejecting approximately 180 kilon of water per second, mixed with cyanide, organics, and other volatiles, a primordial soup being sprayed into space. The heartbeat rhythm remains constant, but the character of the brightness modulation has evolved. Loeb now reports that the variations originate directly from the jets themselves, physically altering the optical thickness of the dust cloud. This confirms 3I Atlas is not a passive reflector, it is an active source generating and shaping its own envelope. To grasp why the sun-locked rotation is so anomalous, we must consider angular momentum conservation. When a comet outgasses, the jets act like thrusters, typically torquing the body and causing wild spin-up, spin-down, or tumbling, the Yorp effect, Yarkovsky, O'Keefe, Radzievsky, Paddock. Over time, uneven heating can spin objects to break-up speeds, yet 3I Atlas remains perfectly stable. Its rotation axis points directly at the Sun with a statistical probability of random occurrence below 6%. One possible explanation is that the jets are not random vents but positioned and timed in a way that provides active stabilization, precisely how we design thruster-controlled satellites to maintain sun-pointing or Earth-pointing attitude. Could 3I Atlas be exhibiting analogous behavior, whether through natural or artificial means? Recent Spitzer data reveal a fundamental transition. Water mass loss rate has surged to roughly 20 times earlier levels, and the pure water ice spectral signature has vanished, replaced by a dark, organic-rich, low-albedo dust component. In plain terms, any outer icy mantle appears to have been shed. We are now seeing deeper interior material, dark, rich in organics, and fragmenting at 180 kilon per second. But if the rotation story is unsettling, the morphology is more so. Spitzer imaging shows a pear-shaped overall plume dominated by a prominent anti-tail directed toward the Sun, not away. Standard models predict solar wind and radiation pressure should blow dust downwind. Here, the tail blows upwind. Loeb explains that this requires unusually heavy particles, grains larger than about a millimeter, where gravitational attraction toward the Sun overcomes weak radiation pressure. This matches Spitzer's finding: virtually no fine dust, no blue scattering, only dark reddish low-albedo material. It resembles shattered brick-yielding pebbles, but no powder, no continuous size distribution. Instead, a pronounced gap missing small grains entirely. That absence is highly atypical for natural collisional or erosional processes. Grinding any rocky or icy body inevitably produces fines. The lack of fine dust implies exceptionally high tensile strength. The material does not crumble easily, it fractures into discrete chunks. Such behavior is characteristic of engineered composites far more than loosely aggregated cosmic rubble. Avi Loeb states plainly, "We should not be surprised if objects arriving in our cosmic neighborhood differ significantly from familiar icy bodies." He urges keeping an open mind. Is 3I Atlas disintegrating naturally under exotic conditions, or is it an object deliberately shedding shielding? Up to this point, everything described is drawn from published observations and peer-reviewed analysis. What follows are the competing interpretive frameworks. The naturalist position holds that we still have incomplete understanding of interstellar comets. 3I Atlas displays unusual traits, perhaps hydrogen ice, extreme dust cohesion forged over billions of years in cosmic rays, or other rare but physical processes. The anomalous hypothesis, championed by Avi Loeb and others, argues that when several low-probability features cluster, sub-6% spin alignment, atypical grain size distribution, stable rotation amid vigorous outgassing, rhythmic modulation, we should seriously explore unconventional explanations without labeling them fringe. Loeb invokes the Galileo Project ethos: follow evidence wherever it leads, free of prior assumptions. And 3I Atlas is delivering an abundance of evidence that demands scrutiny. Context matters. Consider the Interstellar Family album. Oumuamua in 2017 was elongated, tumbled chaotically, showed no coma or tail, yet exhibited non-gravitational acceleration, prompting Loeb's light sail hypothesis. 2I Borisov in 2019 was reassuringly ordinary, a textbook comet that quieted skeptics. 3I Atlas is the hybrid that breaks the pattern. Borisov-like activity combined with Oumuamua-like anomalies, plus entirely new traits, sun-locked orientation and rhythmic heartbeat. Oumuamua acted like a fast fly-by scout, silent, tumbling, transient. 3I Atlas behaves more like a deliberate surveyor, stabilized, active, releasing vast quantities of organics while maintaining precise attitude as it traverses the habitable zone. This surveyor interpretation prompts an unsettling follow-up question: where did it originate? Backtracing the orbit places 3I Atlas's incoming asymptote in the local standard of rest, the average motion of nearby stars relative to the galactic center. In other words, it was effectively stationary with respect to the broader galactic frame while our solar system plowed past it. Picture a buoy anchored in the interstellar medium as stars drift by. The following remains pure thought experiment, not established science. The von Neumann self-replicating probe concept, proposed in the 1940s, envisions advanced civilizations dispatching machines that hibernate in deep space, protected by ice-organic shielding against cosmic rays, then activate near stars. Certain surface parallels exist: stable orientation, rhythmic activity, atypical grain distribution, but correlation is not causation. Natural mechanisms we have yet to model could mimic these signatures equally well. Imagine the sequence: arrival, sun axis lock, 7.1-hour rhythmic pulsing of gas and organics, shedding of outer layers to expose a dark organic-rich core, all occurring as it crosses the habitable zone. The missing fine dust suggests material engineered to fracture predictably rather than powder. Alternatively, the dust may not be passive debris but functional components being deployed. Should the January 22 coherent backscattering data reveal unexpectedly uniform, smooth, or non-fractal scattering properties that would constitute significant evidence warranting deeper investigation? We are no longer simply characterizing ice and rock, we are searching for potential structure. And consider the released volatiles: 180 kilo of water per second, laced with cyanide and complex organics, a primordial soup being broadcast into the inner solar system. Whether seeding, venting, or signaling, the chemistry is present, but time is short. 3I Atlas is outbound, receding from the Sun. If answers require proximity, we may need to pursue. Project Lyra once proposed intercepting Oumuamua with aggressive propulsion, nuclear thermal, solar sail, or gravity assists. For 3I Atlas, the delta V is steeper, yet not impossible. A launch in the near term could conceivably achieve rendezvous by 2040-2050, a multi-decade mission with incalculable scientific return. Close imaging, composition analysis, perhaps even sample return from an interstellar visitor. A brief, speculative tangent, not peer-reviewed, not endorsed by Loeb or mainstream astronomy, but circulating in discussion forums. The 1977 WOW signal, a 72-second narrowband emission from Sagittarius, remains unexplained. Some note that 3I Atlas's incoming trajectory passes within 20-30 degrees of that sky region. Astronomically, that is a broad swath. Sagittarius hosts the dense galactic center and myriad possible origins. Correlation is weak at best. Separately, a few amateur analyses speculate that the 7.1-hour brightness modulation might encode information, a visual carrier wave. Reality check. Periodic variation is routine in rotating bodies with active jets. Pareidolia, imposing patterns on noise, is a known cognitive bias. Absent rigorous signal processing demonstration of non-random structure, this remains intriguing but unsubstantiated. Optical SETI is a legitimate field, yet extraordinary claims require extraordinary evidence we do not yet possess. Still, if jets function as modulated vents, rhythmic exhaust could serve as an energy-efficient signaling mode across interplanetary distances, akin to planetary-scale smoke signals. Should January 22 data show artificial-like structure plus complex non-random modulation in the heartbeat, we would cross into unprecedented territory, potentially activating protocols for techno-signature verification. The surveyor scenario would imply a logical sequence: arrival, observation, possible transmission. If artificial, it could have detected Earth's mid-20th century radio leakage long ago. The WOW. Timing is circumstantial at most, yet here it is, shedding layers, maintaining sun-pointing attitude, traversing our system while pulsing rhythmically. If it has reported home, who or what is listening? That question lingers. So what do we truly know? 3 facts stand firm. First, January 22 provides an unparalleled observational geometry. Second, 3I Atlas displays highly unusual yet not physically impossible characteristics. Third, multiple viable hypotheses compete, from exotic natural processes to non-natural origins. Everything beyond that remains open, and that is acceptable. Science advances by pursuing data, not preconceptions. Watch closely for post-January 22 peer-reviewed papers. Expect opposition surge photometry, coherent backscattering profiles, grain-size distributions, and continued rotation stability tracking. These measurements will constrain the hypothesis space. We may confirm an exceptionally strange comet, or we may uncover something without precedent. Either advances knowledge. Think critically. Question every claim, including this one. Consult primary sources. A.V. Loeb posts regularly on ARKF, freely accessible. If this breakdown helped clarify the stakes in the science, please like the video so others can find thoughtful analysis amid the noise. If you want updates on this and related developments, consider subscribing. Above all, resist the temptation to declare this confirmed extraterrestrial technology. It is not. It is compelling, boundary-pushing science that deserves rigorous, skeptical attention. The data will speak. Let us wait for the data. Thanks for watching. Clear skies.